Good day all. Today we'll be looking at inverse method we'll be using to solve the linear equation. Our question says solve the linear equation using inverse method. X plus 2x plus 3z is equal to 3. Y plus 4z is equal to 1. 5x plus 6y is equal to 2. Now the idea behind inverse method, normally we do represent this in this matrix form will be, it's too small. So in this matrix form it will be 1, 2, 3. Here there is no x, so we'll be representing as 0. Here is 1. Here is 4. Here is 5. Here is 6. We don't have any z here, so here will be what? 0. I will be multiplying it, our x, y, and z, and all of them will equate to 3, 1, and what? 2. So normal algebraic equation can represent this as what? A, which is a constant, your coefficient, your x representing your variables, then your b representing your constants. So you have this times this to give us what? This. And for you to make x out of formula, you divide both sides by a because they are multiplying, and you have this be b over what? A. But in matrix, this is not how we write it. We prefer to write it in its indices form, which is a raised to power minus 1 times b. So this is what we are trying to get. So it turns out that for us to get this xyz, which are represented as x, we just simply what? Find the inverse of what? The inverse of a. You have to find the inverse of a because it's a matrix. We'll find its inverse, and we will then multiply it by what the value of b is. And remember, here is our b, and here is our a, and here is our x. So that's our aim here. So the little problem now is now how to find a inverse. Now a inverse is equal to your adjoint, the adjoint of your A matrix over the determinant of your what? A matrix. Now let us try to get the determinant of our A matrix. Doing that, we will have our signs again, plus, minus, and plus. For our 1, we have 1 multiplying 1 times 0 minus 4 times 6. For the next one, minus 2. Our new matrix will then lie here. So it will be 0 times 0 minus 4 times 5. Then for the last, or for the third column, which is this, we'll be having plus 3 outside, and selecting this 2 by 2, we'll be having 0 times 6 minus 1 times what? 5. Now this is something as 1 times 0 is 0 minus 4 times 6 is what? 24 minus 2. 0 times 0 is what? 0 minus 4 times 5 is what? 20 plus 3. 0 times 6 is what? 0 minus 1 times 5 is what? 5. So this is 1 times 0 minus 24. We are having minus 24 minus 2. 0 minus 20. We are having minus 20 plus 3. 0 minus 5. We are having minus 5. So when we multiply or open the bracket, we have minus 24 minus 2 times minus 20 will be giving us plus 40 minus plus 3 minus 5 will be giving us minus 15. So with our calculator, we'll solve and we'll have our answer to be what? 1. So it turns out the determinant of A is actually what? 1. So we have gotten that. Now let's find the adjoint of our A matrix. Now the adjoint of our A matrix is a bit tricky for 3 by 3, but it's actually easy. For you to get your adjoint, you first of all find the transpose of your matrix, which is just knowing your main diagonal and swapping the other values. Swapping them, keeping your main diagonal in the same place but swapping the rest. So if this is your main diagonal, this will swap with this will swap with this will swap with this. So that's for your transpose. When you get that, then your adjoint will then require you to make each, like this determinant, the way we solve our determinant, we are going to be doing it for each and every single one of these 9 values in this box. For our determinant, we just use one particular row to get our determinant. But for our adjoint, we need to do it for each and every single one of the value. But first we have to do our what? Transpose. So without wasting much time, let us get into it. So for first of all, let's find the transpose of our A transpose, which is something as AT, is what? It's gonna be 1 1 and what? 0, keeping your diagonal what? The same, and the rest you swap them. So 2 will come over here, while 0 will come over here, 5 will come over here, while 3 will come over here, and 6 will come over here, while 4 comes over here. So this is your transpose. We have gotten it. Now we want to get the main thing, which is now the adjoint. For you to get your adjoint, you need to first of all get the transpose from your matrix. We have gotten that. Now we're not going to be getting the adjoint from this matrix and not from this matrix. So using this matrix, we will get our adjoint. Now it is going to require a lot of space. So for that reason, I might be shifting some things. So we have succeeded in getting our transpose. Now we apply our signs, which is plus, minus, plus, minus, plus, minus, plus, minus, plus. Now our adjoint, which will be I'm making it a big matrix. So it will be, for if we're taking this we're starting from here for this one, everything that is not in its row and its column, we will consider those ones and also the sign. So for this one, we'll be having plus outside, we'll be multiplying 1 times 0 minus, remember we're not putting the minus because of this minus here, and we are putting those because that's how to find the determinants. This minus, when we are putting, is when we are considering 6. The same thing for this 2, the same thing for this 4. When we put the minus or the signs is when we are considering that particular column. That's why it is there. It doesn't affect the 6 while you're getting determinants. So this will be what? Minus 6 times 4. For the next one, you have, that's for your 0 part. Remember, we know the difference between this one and determinant is that you are not including your number that you're making reference to in front. In determinant, you put your 1 in front, you put your 0 before, and you multiply every other thing. But here, only what I will put in just the sign. That's that adjoint for you. So minus brackets, every other that is not in each row or column. So we are having 2 times 0 minus 6 times 3. The next one plus, I was looking at this one in 5 ohm. So we're going to be considering this. So we're going to be having 2 times 4 minus 3 times 1. Over to the next one, we're going to be having minus, because we're dealing with this one, we're now moving over to the second one. So in determinant, we will just do for only one line, only one row, and we are done. But in adjoint, we're going to be doing for each and every one of them. So for this one, we'll be having what? Minus, which is this minus in front. Then every other thing is not in this row and column, which is 0, 5, 4, 0. This is this row, this is this column. Anything not in this row and column is what we are considering. So 0 times 0 minus 5 times 4 plus this is what we're not looking at. Everything is not in this row and this column. So we're having 1530. So when we do that, we'll be having 1 times 0 minus 5 times 3. Then minus, that's for this 6 ohm. So we're having 1034. So we're having 1 times 4 minus 0 times 3. Over to the next one, we'll be having 0, 5, 0, and 16. So we're having 0 times 6. We're in the third line now. This is where we are. Anything that doesn't fall under the whole and each column. So we are considering now. So 0 times 6 is what we have written down. We'll subtract it from the minor diagonal, which is 5 times what? 1. Then minus, in each row and each column, what is not there, we're having 1526. So we'll be having 1 times 6 minus 2 times 5. Then plus, for this one, in this row and this what column, we're having 1021. So our matrix, our determinant to be 1 times 1 minus 2 times 0 or 0 times 2. They're all the same thing. So we have gotten our matrix. Now we'll solve further. Now 1 times 0 is what? 0. So this is off. We are having 0 here. So mine 6 times 4 is what? 24. 2 times 0 is what? 0. 6 times 3 is what? 6 times 3 is the same 24 too. It's also 24. Sorry, it's 18. 6 times 3 is 18. It's 18. So 2 times 4 is what? 8. Then 3 times 1 is what? 3. 0 times 0 is what? 0. 5 times 4 is 20. 1 times 0 is what? 0. 5 times 3 is 15. 1 times 4 is what? 4. 0 times 3 is what? 0. 0 times 6 is what? 0. 5 times 1 is what? 5. 1 times 6 is what? 6. 2 times 5 is 10. 1 times 1 is 1. 2 times 0 is what? 0. We go back again. 0 minus 24 is what? Minus 24. 0 minus 18 is what? Minus 18. 3 minus 5 will give us what? Will give us 5. 8 minus 3 will give us what? 5. Now 0 minus 20 will give us minus 20. 0 minus 5 will give us minus 0 minus 15 will give us minus 15. 4 minus 0 is what? 4. 0 minus 5 is what? Minus 5. 6 minus 10 is what? 4. Is minus 4. And 1 minus 0 is what? 1. So we have gotten this. Now our signs will be multiplying each and every one of them. Those with plus are going to remain the same way, but that of minus will be changing. So for that of our minus, the signs will be changing. So this is minus times minus, which is what? Plus. Minus times minus, which is what? Plus. Minus times plus, which is what? Minus. Then minus times minus is what? Plus. So this is our matrix. We have gotten the adjoints. So like normal maths, we don't normally put our pluses. So anyone with plus, we can just simply remove it. It's still the same thing. But those with minus, we leave them. So this is what we now have. So this is our adjoint matrix. So after getting our transpose, we then got our adjoints. And we said the answer is what? Minus 24, 18, 5, 20, minus 15, minus 4, minus 5, 4, and 1. Now we have gotten our adjoints, so now we are good to go. So using that same formula, which is x is equal to a prime a raised to power minus 1 times b, and we say that this is also the same thing as what. So let us get what a raised to power minus 1 will be. We say this is what adjoint of a over what determinant of a, and we got our adjoint to be what, that minus 24, 18, 5, 20, minus 15, minus 4, then minus 5, 4, and 1. Then we will divide it by what? By our what? Determinant, which we got to be what? 1. So this is also something as you're writing what? 1. So 1 times everything here will still remain the same. Nothing will change. So we are getting that our a raised to power minus 1 is also the same thing as what? This, the adjoint, because our determinant is raised to power is 1. So 1 divided in everything still remains the same. Nothing will change. Now, since we have gotten our a inverse, we can now get our x. Our x will then therefore be, using this formula, this one over here, it will then be our minus 24, 18, 5, 20, minus 15, minus 4, minus 5, 4, and what? 1. I'll be multiplying it by our b, which is what? 3, 1, and what? 2. So if we multiply these two, we'll get the value of x, y, and z. So let's multiply. So for us to multiply this, remember, for you to multiply, you multiply this by this, this by this, this by this. That's how we multiply. So doing that, we'll be having that our new matrix, which is also the same thing as your x, y, and z, is going to be minus 24 times 3 plus 18 times 1, 5 times 2. For the next one, we'll be having 20 times 3 plus minus 15 times 1, then plus minus 4 times 2. For the next one, we'll be having minus 5 times 3 plus 4 times 1 plus 1 times 2. So this will give us our answer. Now minus 24 times 3 will give us minus 72. plus our 18 times 1 will give us what? 18, plus 5 times 2 will give us what? 10. 20 times 3 will give us what? 60, plus minus 15 times 1 will give us what? Minus 15, plus minus 4 times 2 will give us what? Minus 8. Minus 5 times 3 will give us minus 15. 4 times 1 will give us what? 4. 1 times 2 will give us what? 2. Now, adding all this, we will get our final answer. So we have our answer to be what? Minus 44. This is minus 72 plus 18 plus 10 will give us what? Minus 44. 60 minus 15 minus 8 will give us 37. Minus 15 plus 4 plus 2 will give us minus 9. So at the end of the whole day, we got our x to be what? Minus 44. Our y to be what? 37. And our z to be what? Minus 9. Now, all this solving that we have been doing is just to get this value, and we have succeeded in getting it. So that's all for this video. Thank you for watching. Please subscribe to the channel, smash the like button if the video was helpful, and I will see you in the next video. Goodbye.